Hello, Miss Etta and Miss Erna. My name is Matthew, and today I'll be presenting SciQA-Bench, a unified benchmark for evaluating retrieval augmented generation systems in scientific domains. Here is today's agenda. I'll begin with an introduction to RAG and why this benchmark matters. Then, I'll summarize relevant literature, explain the methodology, and close with the main conclusions. Let's start with the introduction. We need a basic understanding of RAG before we start. RAG, or Retrieval Augmented Generation, combines two components, a retriever that pulls relevant information and a generator, usually an LLM, that forms the response. This approach helps reduce hallucinations, brings in updated knowledge, and improve factual correctness compared to using standalone LLMs. The urgency for better RAG evaluation is increasing. Every year, millions of new scientific papers are published, and no researcher can keep up manually. At the same time, many scientists now use AI tools for summarization and literature review. However, hallucination and ungrounded reasoning remain real risks. This motivates the need for a reliable benchmark focused specifically on scientific QA, or question and answering. So what are the research questions that we propose? Based on these motivations, this project focuses on three research questions. First, how can we build a unified benchmark for scientific RAG? And how well do current LLMs perform when tested across multiple scientific QA datasets? And finally, to what extent do these models hallucinate or produce unfaithful answers? Our current hypotheses are as follows. First, merging SciQA, SciDQA, and Casper will give richer and more discriminative evaluation results compared to using one dataset alone. Second, state-of-the-art open models like Llama and Mistral will show moderate accuracy, but their performance will vary significantly across different datasets. Third, hallucinations will still occur, especially when the context is long, complex, or multimodal. Therefore, what's the overarching goal of our research? The goal of this research is to build SciQA-Bench, a unified and scientifically grounded benchmark that evaluates how well RAG systems produce accurate, evidence-based, and hallucination-free answers. From the literature review that I've done, we can divide the literature review into four parts. First, the RAG architecture and evolution, the evaluation metrics and frameworks, the benchmarking and challenges, and datasets for knowledge-intensive tasks. First, early RAG models simply combine retrieval and generation. Though over time, improvements such as iterative retrieval, hybrid search, and multimodal retrieval have strengthened RAG systems and reduced hallucination risk. Evaluation and frameworks. Traditional metrics like exact match and F1 can only capture lexical overlap because these are n-grams. Newer frameworks such as BLERT, RAGAS, and FRAMES evaluate semantic similarity, reasoning, and grounding to better reflect real model performance. For benchmarking challenges, despite the progress, major challenges still remain. RAG systems still struggle with generalization, inconsistent retrieval ranking, and long context reasoning. Benchmarks like Bayer, Ruler, and EMNIA highlight these weaknesses. Finally, for datasets for knowledge-intensive tasks, datasets like Trivia QA and Fever focus on factual QA. Meanwhile, scientific datasets like Peer QA, SciDQA, Science QA, and SpeakA introduce deeper reasoning, domain complexity, and multimodal evidence. So what do I expect from this research? Based on the literature, I expect different datasets to reveal different model behaviors. Models will likely perform better on text-only datasets like SciDQA and Casper and struggle a lot more with multimodal datasets like SpeakA. As for the third hypothesis, I also expect that manual evaluation to reveal unsupported claims and higher hallucination rates when contexts are long. Next, I'll explain the methodology. This is the methodology pipeline, or research methodology pipeline, for this research. First, let's explain the dataset. This benchmark integrates three datasets: Casper, with about 5,000 QA pairs with evidence spans, SciDQA, with 2,975 pairs focusing on factual and reasoning tasks, and finally SpeakA, a very large multimodal dataset with over 270,000 pairs involving figures and tables. Together, these three datasets, they provide broad coverage of scientific QA. Next, we move to the data pre-processing. To ensure consistency, the datasets will undergo several pre-processing steps. First, text normalization such as lowercasing and symbol cleaning and fixing white spaces. Then, converting multimodal inputs into textual descriptions. Then we need to standardize all samples into one unified schema with the variables ID, dataset, context, question, answers, and the evidence. Then we need to remove corrupted and missing entries. And finally, splitting extremely long context to fit the LLM limits. Now, what metrics do we want in this research? We have decided to pick 6 metrics. 4 are quantitative metrics and 2 are qualitative. The quantitative metrics are as follows. Exact match, to check whether the model answers exactly, the answers matches exactly with the gold answers. F1 score, a token level overlap between prediction and gold answers. Rows L, an overlap in longest common subsequence. And BERT score, a semantic similarity between embeddings of predicted and gold answers. Now, for the qualitative evaluation, we have 2. There is hallucination and faithfulness. Hallucination checks whether or not the model generates content that is not from the context. So, in simple terms, the model hallucinates the answers. And faithfulness, it is to check whether or not the generated answer is consistent with the context. Now, for the evaluation, first we will input the data, where each input will be a context and question pair, and then there is an answer for as the golden answer. Then each record that is already unified in the dataset that contains the context and question and the answers will be tested on our 2 models, which is Llama and Minstrel. Then we collect their outputs and evaluate them using the automated metrics, then manually inspect a few samples from the hallucination and faithfulness. Finally, we then compare the results across the models to identify any pattern or weaknesses. So basically, the timeline and preparation of the research, first we'll start with the preparation of gaining the data, and then the setup to preparing the data set into a unified schema, and then preparing the models, which is Llama and Mistral. Then we evaluate them with our evaluations. Finally, we analyze the results. Then we may finally report the research into our paper. So what is the conclusion of this research? To conclude, Chapter 1 shows the limitation of current RAG benchmarks in scientific literature, while Chapter 2 explains existing RAG systems and why current datasets fail to capture scientific complexity. Chapter 3 introduces SciQA-Bench, a unified benchmark with standardized preprocessing and evaluation to reveal LLM strengths and weaknesses in scientific QA. Overall, SciQA-Bench provides a needed and rigorous framework for studying RAG in scientific domains. Thank you for your attention, and I hope this presentation brings new knowledge and information to light.